Yeah, coming back to now, let's do the Scitovsky criterion. Scitovsky criterion. It just says that if we have two birds, x and y, and we say x to be Scitovsky preferred to y, if x is Kaldor preferred to y and not y Kaldor preferred to x. Yeah. This is what a Scitovsky criterion said. But important thing to note here is there is another definition of Pareto optimality that is very important for us to know. That is, Pareto optimality can be written in this way. That is, x is Pareto superior to Pareto optimal. X is Pareto optimal if there is no y that is accessible from x such that there is no y that is accessible from x such that y is preferred over x. This is another definition of Pareto optimality that is used, and it is very important to note. It is very important to note for us, as this definition of Pareto optimality is used many times. So there are two important propositions. First is, if all states are accessible from one another, then if all states are accessible from one another, then we say that proposition 1, that is x is Scitovsky superior to y if and only if x is Pareto optimal and y is not. It can be easily proved using the definition of Pareto optimality that we just did. Another proposition 2, it's very important to note, is proposition 2 tells us that x is Kaldor superior to y. X is Kaldor superior to y. Then it must be the case that x is Pareto optimal and y is not. Yeah. Now we can use if and only if here. Other than that, this is about Scitovsky criterion. Now we move to Samuelson criterion. Yeah. Samuelson criterion formally says that x is Samuelson superior to y, which we shall write x is Samuelson superior to y, x is Samuelson superior to y, which we shall write x and y. That is how we define x and y. If the following are true, if there is some z that is in S of y such that x is preferred over z. To put it another way, we say that x is Samuelson superior to y if for any z accessible from y, there is a w accessible from x such that x is Pareto superior to z. Yeah. X is Caldor superior to z. So it just says that if if there is some x, it just says that if there is some z that is accessible from if there is some z that is accessible from y, there is always a x, there is always a w that is accessible from x such that x is Pareto superior to z. Let me make a diagram to make it more clear. It just says that this is U2, this is U1, this is utility frontier of X, this is utility frontier of X, this is utility frontier of Y. Okay, it just says that if this is point Y and this is point X, wherein this is utility of y, this is utility of x. Okay, so if we take any point z, u of z, that is accessible from y, there will always be a point in x such as u of w. There will be always a point in x such that u of w that is Pareto superior to point z. Yeah. So there is the limitation of Samuelson and Scitovsky Samuelson, Scitovsky and Caldor. All three of them have the limitation that if the allocations are mutually accessible, then it's very hard for us to to come out with a solution, to come out with a proper way that one is better than the other.